Man.
Uprising.
Alrighty, so lesson 4.5, graphing using intercept or slope-intercept form. We're going to first practice and just remind ourselves on how to solve for y. That's super important when we're graphing. So I'm going to draw my line down that equals and create that border, that fence there. And I'm trying to get y by itself. So if it helps, you can put a little box around it, circle, highlight it, whatever it happens to be. But you're trying to figure out how do I get everything else around that gone. So the opposite of multiplying 10 is I'm going to divide everything by 10. So when you multiply and divide, you complete everything. So we have 1/2 x plus 1 equals y. And when you're writing your final answer, again, we want to write this so that it looks like this format. Oops. This format up top here. So I want to rewrite that. So it's y equals, my x is going to come first, and then that plus 1, and then I can put a pretty little box around this with those bows Miss Olson loves so much. So what I need you to do is to push pause. Try these next 3. You're just polishing up your skills and testing what you don't remember, and then you can push play and check your answer. Alrighty, so you can check your answers, numbers 2, 3, and 4. Push pause if you need to, otherwise we're going to keep going.
Okay, now we're going to look at a few more examples here in example 2 with finding the slope and the y-intercept of a line. And I think before we really get started here, Ms. Zarnes and I really want to stress to you what slope-intercept form is. So in math here, we're not that creative, right, with our names and titles for things. So if you think about this, it says slope-intercept form. Well, what's listed first? Well, the word slope is, so we're going to expect that when you're writing an equation in slope-intercept form, that you list your slope first and then your intercept. Okay, just like we have over here with the equation y equals mx plus b, you're listing your slope and then your y-intercept. So example 2, identify the slope and y-intercept of the equation. We're going to do example A, and then you're going to try B and C on your own. So what I find helpful to do is to put a 1 in front of that x. So my slope, y is already by itself, so I can just simply identify the number in front of x, which is 1. And then my y-intercept, super, super important that you bring that negative with, that's in front of that 3 along. So your y-intercept is -3. I'd like you to try B and C, check your work, and if you need to pause the video, go ahead and do so. Okay, so please check your answers for example 2, B and C. Make sure you're getting the right slope and y-intercept. Okay, looking at this next problem, I've zoomed in so you can't see the directions, but you have them in front of you. For example 3, it says solve for y and then identify the slope and y-intercept. Ms. Zarnes and I decided we would do example 2 for you because we thought of the 2 problems, that was the one that was more difficult. And it's the one that's probably going to need a little more space. So what you're going to want to do first to get y by itself is draw your line down from your equal sign. Then you're going to subtract 3x from both sides. So you're going to cancel the 3x's, have 2y equals, and then remember we want to get in the habit of putting our x, or our slope rather, in front of our y-intercept. So this is going to equal -3x plus 8. Now y still isn't by itself. You've got a 2 in front of that y that you need to get rid of. So divide all of your terms by 2. So y equals, and it's just fine that there's a fraction here, -3/2 x plus 4. This here, I could then put the box around it and draw my bow because I have y by itself. I know I've kind of written over some stuff, so I'm just going to continue to work down here. But M stands for my slope. So my slope in this problem is -3/2. B is my y-intercept. My y-intercept for this problem is 4. And then if I want to write my y-intercept as an ordered pair, I'm going to write that as, remember, when you write your y-intercept, you let x equal 0, and that's still the case. So this right here is your y-intercept written as an ordered pair. So now what we'd like you to do is try number 1 on your own, and then check your work.
Alrighty, all you should be doing right now is checking your work. Remember that your M represents the slope. That is always the number before the variable x. And B is your y-intercept. That is whatever you're adding, subtracting at the end of your equation. And then your intercept is always written as an ordered pair. Alrighty, on this next example, so it's on the next page, like Miss Olson said, on the last one, she picked the second equation because we felt like it was a little bit harder. On this one, I'm doing the same. I'm checking for, in this example, you don't have the directions, but they should be on your note packet in front of you. You're going to solve for y, and then identify your slope and intercept. So I'm still going to start by drawing my line down that equation, or sorry, down the equals. And I'm trying to get y by itself. So I'm going to leave this all alone. And I have to get rid of anything that's being added or subtracted. So I'm going to get rid of that 8x by subtracting 8x on both sides. And I'm left with my x's disappear on the left. Don't forget that minus sign in front of your 10, so it's really a negative 10y, equals negative 8x plus 14. And I get plus 14 because this 14 right here is positive, and I get a negative 8x because of the negative 8x right there. But again, that y is still not by itself, so I need to divide everything by that coefficient. So I'm dividing everything by negative 10. So I have 1y equals, and like Miss Olson said, fractions aren't bad, but we need to remember 2 negatives make a positive, and this fraction isn't going to be nice, so I'm just going to reduce it. So I can take out a 2 from both of them, so I end up with a positive 4/5 x, and again a positive and a negative gives me a negative, and 14 and 10 isn't going to give me a nice fraction, so I can just reduce it and take out another 2 out of both of them, so I have 7/5. And now since y is by itself, this is my perfect slope-intercept equation. And the same thing in that last example, I kind of ran out of space, so I'm going to just write down below, my slope is 4/5. That y-intercept is now negative 7/5. Don't forget that minus sign in front of it. And then that ordered pair, that y-intercept, I'm actually going to write in, here is 0 and then negative 7/5. So what I'd like you to do is push pause, try the first one on your own. Remember that slope-intercept must have x come first. So y equals mx, or number x plus b, and then check your work. Okay, on this one, check your work. Please make sure that you notice that y equals is not mx plus b. So it's kind of switched around. So really, we need to rewrite this so that x comes first. So we have y equals, and we have to rearrange them. So we have negative 6x, and that's a positive 19. And now this is what I use for my slope. So my slope is negative 6, y-intercept is 19.
Okay, this fifth example is all about graphing, which we love so much. We've got 5 steps here for graphing. The first step is to make sure that your equation is written in the form y equals mx plus b. Some of the equations, like if you look at the two examples that are provided are already written in y equals mx plus b form, so you can skip that first step. Then you're going to identify your slope. So if I'm doing example 1, I would identify my slope first, then I'm going to identify my y-intercept, and then I'm going to graph them. And when it comes to graphing, the first thing you're going to do is plot your y-intercept and then use your slope to find another point. So I'll kind of walk you through this first example here, and then you can try the second one. So first, I want to find my y-intercept. And like I said, this one already has, or is in the form y equals mx plus b. So I skip that first one and just move on to identifying my slope. So my slope for this one is 1. My y-intercept is 5. And note with your slope that I'm not writing 1x, it's just 1. My y-intercept, writing it as an ordered pair, is 0, 5. Now to graph this, first thing I'm going to do is plot my y-intercept. And remember, your y-intercept is on your y-axis. So I'm going to plot my point right there on that y-axis. And then I'm going to use my slope to find another point. And in this case, my slope is rise over run. I can rewrite a slope of 1 as 1 over 1. So I would rise 1 and run 1. Now if you can see, if I rise 1 and run 1, I'd be here and that's off the grid. So what I'm going to do instead is from my y-intercept, I'm going to fall 1 and go to the left 1. Because rising 1, running 1 is actually the same thing as negative 1 over negative 1. So down 1 to the left 1. You can do that a few times. Go down another 1 to the left 1. I don't know if Ms. Zarnes and I are going to be looking for a certain number of points, but the more points that you have on your graph, the more accurate it will be. And then make sure you draw an arrow in both directions. So now what we'd like you to do is try example 2 and check your work. So here is the graph for the second problem. You should have gotten a slope of 2 or 2 over 1, right? So you can write this as 2 over 1, and then your y-intercept was negative 3.
Okay, for example 6, you're going to write an equation of the line in slope-intercept form. So we're going to take this graph, and we need to write an equation in this format. So we know that we need to fill in both m and b. So we need to find the slope and the y-intercept. And using this graph, we can find that intercept by following our y-axis. So wherever our line is, which happens to be right here, that's at a positive 1. So our y-intercept is a positive 1. So I'm going to kind of make a little flow chart here for you. Then our slope, we are going to count the rise and the run. So our slope is rise over run. You should have a lovely video by this time ingrained into your head with rise and run. So if I were to go from this point and count my rise, I'm going up 1. So my rise is 1, my run is 1, 2. So now my slope is now 1/2. All I have to do is put those pieces together in one full equation. So y equals 1/2 x plus 1, and that is your equation. So what I'd like you to do is push pause, try example 7. All you have to do is match graphs A and B with either 1 or 2. Match each of those graphs with the correct equation, push play, and check your work. Alrighty, check your answers. Number 1 should match with B, number 2 should match with A. One of the steps I use is checking the intercepts first and matching those. And if they happen to have the same intercept, then match your slopes. You can skip example 8, so I know you're super excited right now, but we're going to flip to the next page.
Okay, so we're getting near to the end here. We're going to talk about parallel lines, which are two lines that have the same slope and never intersect. So, and I'm sure, hopefully you've heard of lines never intersecting, or two lines that are parallel never intersect. So we're going to look at example 9, which is asking us to tell whether the two equations are parallel or not. We're going to do example 1, and then you'll try example 2 on your own. So first, looking at example 1. This first equation here is nice because it's already in the form y equals mx plus b. But, oops, if you look at your second equation there, it's not. Well, y is by itself. Your slope and your y-intercept really do need to be switched. So if you want to just flip those, y equals 3x, and then that's a positive 4. So then it's very, very simple to identify your slope. Remember, your slope is the number in front of your x, right? So my slope for this one is going to be 3, and my slope for the second equation is also 3. So because both of these equations both have the same slope, that means these two lines are parallel. So I'm just going to write parallel lines. So if the two lines have the same slope, they are parallel. If they do not, they are not parallel. So why don't you try example 2. See if you get two of the same slopes or two different slopes, and then make sure you write a sentence or statement saying if they are parallel or not. So looking here at example 2, we got that the two lines, or the two equations rather, are not parallel because we have a slope of 5 for one equation and a slope of -1 for the other.
Okay, for this last example, example 10, you need to determine which lines are parallel. So as you can see, I've color-coded mine because it's kind of hard to read on your graph. So if you'd like to do something like that on your own, you can pause the video and start that. But we are going to count the rise and run of each of these. We're going to find the slope for each one. So for line A, I'm going to go up. So really I'm going up 1, 2, 3, 4. So my rise is 4, and my run happens to be just 1. I'm going to simplify that to 4. For B, those are the two blue dots. I'm going to count that rise. So I have 1, 2, 3, 4, 5. So my rise is 5, and my run is also just 1. So I'm going to simplify that to just 5. And then that very last one are my two green dots. So I'm going to rise 1, 2, 3, 4, 5. And then I'm going to run just once and simplify that. So we know from Ms. Olson just now that parallel lines have the same slope. So if I'm going to identify my parallel lines, it would be line B and line C, because both of those slopes are 5. That means that they will never intersect. Once you have decided what is parallel, make sure that you write it as a statement. So our final answer should be something along the line as line B and C are parallel. And then always make sure you identify your final answer, because these can kind of start getting messy. And Ms. Olson, I love when we know exactly what your answer is.